Okay, folks. Welcome to this session on Apache Ranger and how we extend authorization beyond Hadoop. My name is Ramesh Mani. I work for Hortonworks. With me is Abhay Kulkarni. We both together going to present how we are going to extend, how we are going to use the Apache Ranger and extend it beyond Hadoop's ecosystem. Also with me is a team from Pivotal. Alex and Vinith, they are going to show us on how they utilized Ranger's framework in order to secure their MPP SQL engine Apache Hawk. So thing is that what we are going to look over is like how we are securing Hadoop ecosystem and few security features, and we will go what is Ranger, why Ranger, and what it takes to extend a component or extend a component in order to enable Ranger for authorizing and auditing. Okay. So let's go a few slides. Yeah, let's go over the basics of securities. So when it comes to security, the three A's comes into picture: authentication, authorization, and auditing. So what is authorization? You identify a person within an ecosystem, like in a system, who is that person who is therein, okay? And what he's doing, and what he's going to do, that comes into the authorization stage. Where you will identify and an administrator will be giving a rule or set of policies saying that, okay, hey, this guy is in there, okay, he's going to do certain operations, and we are going to authorize by setting up a rule. So that is authorization. And the next part is auditing. Okay, how we are going to audit? That person came in, he did some operation, and what he did, at what time he did, so in order to identify that one, we need auditing also. In Hadoop world, like HDFS, Hive, HBase, all these ecosystem components, they have their individual native ACLs. Like in case of HDFS, the point of resource access is like its file system, the folders and directories, and then an administrator, he is going to give a read-write execute access. He'll be going individually, and he has to give read-write access, and then whatever the auditing is done, it is natively to that component. Like he will have its own auditing log, somewhere it generated, and it will have in its own auditing structures and things like that. Same way, Hive, it will be database, tables, and columns, and an administrator has to go in and he has to give grant commands, in order to give a permission like a create, insert, or whatever the permission he is going to do. So in big data world, these things grow enormously, like all these file structures, tables, and data. And in order to do somebody to administer this and go ahead and create some scripts, it's really cumbersome. And in order to answer a question like hey, what happened at this time? Who is the user who is going to who got access into this and what he did? Okay, those kind of questions. If you throw it at a ecosystem, Hadoop ecosystem with the native ACLs, it's very cumbersome to do to get an answer easily, because he has to do a lot of work to get that done. So that is where Apache Ranger came into picture. So what is Ranger? Okay, Ranger is a framework. Okay. It is going to enable, monitor and manage comprehensive data security across Hadoop ecosystem's components. So why Ranger? Yeah, the de facto is like it provides a single pane of glass. You don't need to go individually to each and every component to give access, and you don't need to write a script. It's all centrally administered. All you need to do is like log into Apache Ranger's central portal, where you will find all the components registered, and from there, Ranger is going to take control and do authorization and auditing. So this is a bigger picture of what current Hadoop ecosystem and Ranger taking control of its the policy, authoring a policy and giving authorization to a user who came in, and and also auditing. If you see this one, there is a centralized portal, Ranger admin portal. You have to log in into that, and all the services of Hadoop ecosystem, HBase Hive, all will be there as a wizard, okay? And within all this ecosystem, okay, we will have Ranger plugin, okay? Ranger plugin's job is to have, the policies which are there stored in Ranger admin, and it will be caching it and use that as a point of single point to, do all the authorization which we do, and at the same time, it is going to, send events for auditing also. Auditing is sent to different destination. It's all configurable. It goes to Solar, HDFS, Log4j, and Ranger admin itself is going to fetch its audits from Solar. So it is very sophisticated, and it goes, you don't need to go scramble out, to n number of places to find, what has been done. So this is the service manager when you log in into Ranger admin. All these wizards which are showing are the services, the individual Hadoop ecosystem components, okay, which are registered with Ranger to give authorization and auditing. Okay, so we just here click on one of those components like HBase. Okay, we will see an authoring page where you will maintain a policy and against a resource for that particular component. Say in this case, HBase, the resource for this HBase is like HBase table, order, HBase column family, order details, and columns, every columns. For this resource of HBase, we are going to maintain a policy to read for this analyst, okay, group called analyst. So analyst gets a read operation for these tables. So this structure, how we are authoring the policy is uniform across all the components across the Hadoop system, whether it is HBase or Hive or HDFS, whichever component, it will be the same. You will be identifying the set of resources the corresponding the components has, and you will be maintaining the policy against this. And from there, it's all Ranger controlled. So, and this slide, it shows how the auditing is. Okay. It is also at the centralized location. You just go click that audit tab, and you will find audits for all the components which are managed by Ranger. And if you see this one, the auditing is very, very straightforward. It gives exactly what policy that authorized that particular user at what time, what is the user and what component, and what is the resource and what operation they did. Here, if you see this first two slides, select is an operation done for this employee internal table, and who did that authorization? Ranger ACLs, and even the IP address and the cluster name. So whatnot, it gives a very sophisticated structure, and you don't need to go or scramble or write some number of scripts to get all these details. Okay, so it's not only the resource based. See, all these policies, what we say is like it is maintained against a resource. Resource is like each component has its own resource, like HBase has its table and column family. Ranger also provides the flexibility to maintain policies against tags. In this case, the security based, the classification based security comes into picture. Okay, we classify entire all the systems which are registered with a Ranger, like in case of HDFS, files and folders, and in case of Hive, tables and tables, columns, and column families, all are like going to be tagged. Like say, in case of a column has a sensitive data like PII, or a file system in HDFS has PII data, we will create one tag and tag across all the systems. Okay, and give a policy for the tag saying that, okay, this tag, whoever acts, let's say in case of analysts, okay, this tag is attached to this PII data tag, and we will give a policy like a read access to this tag, and that's it. From there, within the ecosystem, whoever is getting access to that particular column, he will have a read access or nothing else. So it is a classification is like a one level above the resource. And what it takes to do this all, it's nothing but the two crux of Ranger, the service definition and the plugin side. So what is service definition? It's just a JSON which gives the details of what all the resources which it is going to have it for each services. And plugin is another key component of a Ranger, which will give the interface to write your own authorization and auditing a mechanism. So we will go further more into this detail. For that, I have Abhay Kulkarni, and he will go over much more detail of what is happening behind this authorization and auditing interfaces and how it is glued into how to extend it to any of the Ranger, any of the other services, like whatever it is. Okay, you will hook into Ranger, and there it goes, your auditing and authorization. So I'll call Abhay. Yep.
Hello. Thank you, Ramesh. So far, I think we have seen how Ranger can be one single pane solution to everything that is regarding authorization. Now the question is how easy it is to use exactly the same infrastructure and the same look and feel for enabling any other component. It doesn't have to be Hadoop component, it can go beyond Hadoop, but any other Hadoop component as well can be Ranger enabled using certain simple steps. So at the heart of the Ranger is something called service definition. That is the essentially your components access requirements. What are the resources in your component, as well as what are the different kinds of access types that are supposed to be there, and few other things need to be specified, and that is collectively that specification is called service definition. So in terms of Ranger software architecture, the entire Ranger is essentially what we call a stack model. It is essentially an interpreter of a service definition. So a set of specification in the JSON format is taken, and that is used to prime the Ranger infrastructure to develop internal structures which can implement your access policies, as well as provide a common look and feel for policy authoring. So as a result of the result of this service definition process, what you get is a component specific GUI, then a policy validation. So based on what are the access types as well as resources that are specified in your JSON, service definition JSON, you automatically get these kind of things out of the box. And obviously you get a policy driven enforcement of access control and audit logs. So let's skip ahead a little bit and see what is a service definition. So this is basically a specification of what are the resources, what are the access operations, and there are a few advanced features such as context enrichment and dynamic policy conditions. So dynamic policy conditions give some open access to any other thing that cannot be covered by the Ranger model. We'll go over that very quickly. And once a JSON for the service definition is developed, it can be put into the Ranger using a simple curl command. So let's look at some of the sample service definition JSON. So here you specify most of the important parts in here are really access types and the resources. So this is a simple sample kind of application in which your resource is basically a path, a file name, and you want to put read, write, or execute accesses on those paths that are specified. And there are, so these are the main parts of it, and there are certain context enrichers and dynamic policy conditions that too can be specified. So if you want to look at a real a complicated, fairly complex service definition which is used for a tag, for example, then it can be pretty complex, and you can see there are validation regular expressions and descriptions, and all of these can be used by Ranger to come up with a proper policy editing screens. So going back to Going back to the Ranger process architecture and modules. So the first part of this process architecture shows different modules which are used for policy authoring, then policy validation, and policy persistence. All of this you get pretty much for free once you develop a JSON for your component service definition. So all of this is essentially comes out of the box for free. The part about policy synchronization also comes out of free. It is the module which synchronizes the policies with the actual component. Actual component requires some kind of a glue code, which is on the right, and the policy evaluation engine and audit infrastructure also comes for free along with the Ranger infrastructure. So in order to develop a glue code, which is actually really the component dependent part, that requires essentially providing a service definition with a glue code, and you get a Ranger enabled component. So how does this thing work? So there are certain basic code interfaces that Ranger provides, and the most important of that is Ranger based plugin. So a typical component architecture will look like this. On the right hand side, you have the actual component code, which is doing whatever work it has to do. Most of the components would have an authorization interface, which is called for every operation. So that is part of the component code, that if there is any operation that is requested, any access request that comes in, API such as authorization API would be called, and depending on the results of that authorization API, the operation will be either allowed or denied. So typically when you Ranger enable a component, you have to change the authorization, you have to implement the authorization interface using the Ranger's data structures. So the most basic of that is a plugin. So for a simple sample app, authorizer interface could look something like this. There is an interface authorizer which is initialized when the component initializes, and it supports one API such as authorize, and in our sample app there is a simple thing like a file name and what is being accessed, what is the type of access that is requested, who is the user, and what is the set of groups that user belongs to. That is a typical authorization interface that a component would typically support. And corresponding Ranger authorization implementation would look like something like this. So it would re-implement this interface, and it would provide obviously the initializations. During the initialization, the Ranger base plugin class is initialized, and if you need to process the results of the authorization request, such as want to do something special thing, audits come for free in any case. But if you want to do something very special, then there is a way to plug in your own result processor in the base plugin. Once this plugin is initialized, every time the authorize API is called by the component, all that this piece of code is the actual glue code that will work between the component and the Ranger. All that it would do is map the incoming request, which is file name and access type, into Ranger specific access request. Okay, so you can see that here there is a Ranger access request impl object that's created out of the incoming request. So that maps the incoming resource and access request into the Ranger specific request, and simply is access allowed API on the plugin is called. You don't even have to actually re-implement that API. That API by itself takes the request and processes it, runs it through the policy engine. Now the policy engine works off the policies that are downloaded from the Ranger admin, all the authored policies that are downloaded, and that is done periodically. It is not in the part of the evaluation loop. So evaluation loop is pretty fast. So it goes through all the policies, runs the policy engines through, and it comes out with a result which is typically provides two separate values. One is audit required, and if it is required, it's already audited, because by default the result processor is a default audit processor. So depending on how you configure your audit to go to maybe Solar, maybe to HDFS or to the database, it would log the audit and it will come back with a result which is essentially a Boolean. whether it is to be authorized or not. And that's basically get is allowed gives you the authorization result. So it is as simple as writing a few lines of code if you don't have any specific customization requirements for post processing that is required. So that is as simple as the writing a page of code to plug in your to enable your component for the for Ranger authorization. So that's basically, there is a lot of stuff that is actually available about how to do the access request mapping, but that really depends on the component. How are you going to map your internal incoming resources onto the Ranger specific requests? And that pretty much concludes my part. So I think we have more stuff coming in with a Hawk. There is a real life implementation and experiences that Pivotal team had about how they implemented the Ranger plugin for Hawk. And any questions? I think what we would do is probably we'll take the questions after your presentation is over. So please hold all the questions. And Ranger is a top level project, and of course we have various different ways to contribute, as well as there are mailing lists that are provided here. Want to so you have this one? Here. This one. Okay. You want to go for the kill?
Hello. Hi, everybody. My name is Alex Denisov. I'm software architect at Pivotal and a committer on Apache Ambari and Apache Hawk projects. I'm here today to tell you a story about how Hawk met Ranger. I'll briefly go over introduction to Hawk and talk about our integration architecture between Hawk and Ranger products. We'll review the resource and privilege model that we use in Hawk as applied to Ranger integration. I share a little bit about our development experience and share some details about current and future work going on. What is Hawk? Hawk is basically a SQL on Hadoop engine. At its core, Hawk is an MPP database, which is a massively parallel processing database, which offers advanced analytical performance and interactive query execution to people mostly used by data analysts and data scientists to get insights into their complex data at scale. Currently, Hawk is an Apache incubator project working towards its graduation. However, it's not a new project. Hawk has a very rich legacy and history. There are a few ways to develop a SQL on Hadoop engine. You can start with an execution framework native to Hadoop, such as MapReduce or Taz, and build a SQL layer on top of it. Alternatively, you can take an MPP database which knows how to run and execute queries on a cluster and teach it how to work in Hadoop and work with data stored in Hadoop. So obviously, as you can guess, Hawk follows the later approach. It's all started in the late 80s with the Postgres. Since then, Postgres has a lot of time to mature its technology, and right now it's one of the most popular database open source products on the market. But Postgres was designed to work on a single node, and once data became big data, you can't really process and store a lot of data on a single node. So what if you could make Postgres run on a cluster of machines? And what if you can make Postgres on each machine process its own subset of data, shuffle data as necessary, and send aggregated result to some central place? That's exactly what MPP database is, and that's what happened with the release of Greenplum, which is MPP analytical database, and that happened around 2005. Since then, Postgres and Greenplum were developing, and by the time Hadoop became popular, later it was only natural to make Greenplum and make it work with Hadoop. And that's how Hawk was born at around 2012. We open sourced Hawk as the Apache product in 2015, and since then it became open source incubator project. If you want to learn more about Hawk, there is a session tomorrow where my colleagues will be presenting on Hawk integration with Hive. Please attend if you're interested. There are a few advantages that Hawk provides on top of similar SQL on Hadoop solutions. I don't have time to go over all of them, but we provide a lot of SQL compliance and advanced analytical performance, integration with machine learning, scalability, and advanced cost-based query optimizer. Along with all these advantages, Hawk inherited from Postgres and Greenplum its authorization model. It's a standard role-based access control model where privileges are granted to resources for specific users. In this example, administrator grants select privilege to a specific table under a specific schema to a user and does it using command tool SQL statement. This is a well-proven model which works perfectly well. So why Ranger? Well, the thing is, Hawk is not deployed by itself. It's deployed as part of overall Hadoop cluster where other services such as HDFS, Hive, and others are present. And if there's no Ranger, then administrator has to go and manage access control lists and manage auditing information separately for each component in ways specific to that component. And Ranger specifically was created to fill that gap. So we moved from individualized management to centralized management, where Ranger provides all these green boxes, Ranger Policy Manager, Policy Store, and the plugins which components embed. So it's only natural we thought, okay, we're going to be participating in that ecosystem. Let's just go and embed the plugin into Hawk, and we're going to be done, right? Easy. Well, not quite. The problem there for us was that Hawk is written in C, whereas the plugin is written in Java. So the first step we had to decide is how we're going to bridge that gap. And the way we did it, we introduced a component called Ranger Plugin Service. When Hawk is configured to work with Ranger through the configuration parameter, the flow goes as follows. users submit their queries to Hawk, and Hawk checks with Ranger plugin service using REST APIs and say, hey, user Joe tries to go and access this table. Does he or she has a permission? Then Ranger plugin service delegates the decision to the Ranger base plugin, and that plugin, based on the policies which have been defined by the administrator, goes, evaluates it, and provides a decision back to Hawk. Another component we have to build was a jar file, which goes and gets deployed on the Ranger policy manager, such that when you use a wizard to create a policy and you can go and look up resources, that plugin goes and talks JDBC to Hawk to discover what tables and schemas are present in Hawk, and that makes user experience easier and better. And we also utilize the auditing framework that Ranger provides. The Ranger-based plugin can be configured to send auditing entries to the audit store, be it a local file system, HDFS, or a Solr instance. So a lot of benefits came when we integrated with Ranger. So once we figured out our deployment policy, we needed to look at our resources and privileges. And we have a model of the resources which is hierarchical in nature. We have databases, table spaces, and protocols at the top level. Then schemas and languages live beyond that. And then tables, secrets, and functions, they live in the context of a schema. Luckily, Ranger supported hierarchical resources, so check mark there. After resources, we looked at the privileges that we need to support. And those are typical privileges you can find in the database system. Note that it's kind of sparse matrix, right? You can use select privilege on a table and sequence. You cannot use it on something like table space or a schema. Unfortunately, at the moment, Ranger UI doesn't allow us to restrict which privileges can be applied to which resources, and that would be good enhancements for the future releases of Ranger. So when we defined those, we created the JSON file that Abi was presenting before, and we uploaded the JSON file into the Ranger admin. Once you do that, you get this Hawk tile down there in the Service Manager panel, and you can use the standard wizards for defining a policy. This is an example of defining policy for a table. And you also can view your auditing entries. Here you can see that one user has been granted access, and another user has been denied because there was no policy authorizing such access for the user. I want to share a little bit about our development experience. It was a very good experience. There was a lot of positives there. The framework is very easy to use. It just been a few months before our inception that we needed to do that until the feature was ready to ship. Ranger is very metadata driven, so whenever we define our resources and privileges, all that was needed was creating JSON file, uploading it, and right out of the box we had experience when we could experiment and work with that integration. It's pretty well documented and well supported by the community, and really extensible framework. If you need to go one level deeper and create custom things, you can do that. There are ways to hook it up. There were a few challenges, of course, along the way. For example, for our hierarchical data model, we could not define policies directly on the middle leaf. So for example, database contains table spaces and table spaces contain tables. Right now, I don't think it's possible to create a policy directly for the specific table space. There are ways around it, but support for that would also be desirable in the future releases. Once we started working with the security SSL and Kerberos, we found that documentation was not that readily available as for the basic other core components. And the example of using Kerberos and SSL for the sample applications that Ranger provides would also be beneficial for people who want to implement it. And finally, there is a very rich and robust deployment and configuration infrastructure which ships as part of Ranger and supports plugins which ship as part of Ranger. Not so much for us, since we are not part of the stack, we couldn't use that architecture for deployment and configuration. We had to write it ourselves, which wasn't a big deal, but again, would be beneficial if that our infrastructure also provides flexibility for those components. Currently, we're working on supporting for clusters secured with Kerberos authentication and high availability of our Ranger plugin service. This actually features already done, and they're going to be shipping at the end of the month. We're also thinking about that Ranger plugin service, which we have written, It benefits us because Hawk is written in C and provides the gap, closes the gap between C language and Java-based components, but it can also help other components as well who are written in C or other languages which are not Java. So on the roadmap, first we can think of contributing that to the Ranger project itself. A little bit down the road, we plan to implement secure transport between Hawk and Ranger plugin service and Ranger admin. And finally, we want to provide user-friendly configuration for this Ranger plugin service in Apache Ambari. So in summary, we integrated Apache Ranger with Apache Hawk. Our journey was short and pleasant. We are grateful for support we received from Ranger core community. And this is our story. Thank you. I think we're open for questions if anybody have questions.
Yep. Sure. So when we have, it's on the same cluster, we have Ranger plugin for HDFS, right? For Hawk, are we going to have two separate plugins individually? For one for Hawk and another for HDFS, or will it be a common plugin?
Well, the question was if you already have HDFS, which already has a plugin, and you have a Hawk, would it be separate plugin or separate ones? I believe HDFS plugin is embedded into HDFS name node or data node, whereas for Hawk, we have to run this separate process on the Hawk master, which is Ranger plugin service.
Okay. And anything in the roadmap to support Greenplum, basically Hawk is the same as GBDB engine, right?
You want to take
Not in future.
Not in the plan right now, but if there's a need that surfaces up, then yeah, we can definitely consider it because the model should be easily portable for Greenplum.
Right. Okay.
Yeah, so yeah, we should talk. Thanks.
Please.
How Hawk is different than Presto, and what are the advantages of Hawk over Presto?
You want to take this?
Yeah, that's a longer conversation. Maybe we can chat offline, and it's someone not related to Ranger, so maybe we can take Ranger questions first.
Yeah.
Yeah. Sure.
When was the estimate time the Ranger plugin would be available for Bari?
By
Ambari support for Ranger plugin for Hawk or for Hawk? It's on the roadmap. I'm not sure what exactly time frame would be. Right now, it's possible to configure it using command line tools, and Ambari configuration will come sometime later. I think our first priority would be secure communication, and Ambari support will come after that.
So those of us that own HDP with important words in Pivotal, can we submit a case to have you help us with that?
You can
Service and everything?
Yeah.
you can definitely submit the case, of course.
here.
How do you support the dynamic column level masking in Hawk?
How do we support database
Dynamic
level?
Dynamic, we don't yet. It's on the roadmap. Yeah, right now we don't support it, but it's on the roadmap, so we'll be working on that as well. Yeah. Iterative development.
So how do you deal with the data acquisition and Ranger, right? So I know that we have REST on HDFS, but then we have to deal with the PII data and then when it's streaming it about
Column masking.
Yeah, that's what we have at the Hive level. We have a column masking. Okay, so you can mask the data, and even filtering also is there. So you can define policies against those filters, and have the filters there in the policies. And when you get those,
each column level per table.
yeah, you can mask that column based on what you're going to define for that column.
And can we define any particular encryption strategies like there might be like data masking or all these PGP define one-on-one?
It's not specific to any algorithm. Actually, there are custom masking criteria which are provided there. Okay, one is that you can mask by its SHA, any of the SHA's algorithm, so you can mask that. So it is just a predefined set of masking criteria you have for that.
If we have Autolux SDP and SDP in the same cluster, does Ranger work smoothly across?
Sorry, can you repeat the question?
So if we have Hawk in the same cluster as HDB, does Ranger work smoothly?
Yes, it shouldn't, it depends on, what you're going to, it's a load of that system, right? It doesn't matter actually. Wherever it is available, it is going to,
Yes, it does. And
authorize.
basically, yeah, that was the whole idea of, like if you have HDB, like Hawk and HDP together, they can all use the same instance of Ranger, and that's the single point of a policy administration.
Because the same nodes have data nodes as well as Hawk segments. So,
Right. I think that is it. Thank you very much.
Yeah, thanks guys. Yeah.